Good evening. My name is Michael. I'm actually a web developer, just as probably as you are. And I want to talk slightly about security, about cross-site scripting, about PHP, about content security policy, and so on and so on. We'll also touch the barbecue thing, don't worry. We'll touch that thing as well. I got a question before if this session is vegan friendly, and yeah, it is. Don't worry, it's vegan friendly. No animals were harmed during making of this presentation. But we will be talking about beef, and we might be using it as well. Let's see. So we will talk about a cross-site scripting attack. Please raise your hand who knows a bit about cross-site scripting attack. Okay, and who has been hit with the cross-site scripting attack? Oh, good luck. That's cool. So, cross-site scripting attack was first described by a guy in Microsoft in '99, which is like, I don't think, almost 17 or 18 years before. And the name cross-site scripting was coined by the Microsoft team at 2000. So this attack is known for 17 or 16 years, which is quite a lot. And still this attack, cross-site scripting attack, is like in top 3 attacks according to OWASP. OWASP is a organization, Open Web Application Security Project. And they are like ranking the web attacks by their market share. And cross-site scripting is still like top 3 in top 3. Sometimes it's top 2, sometimes it's number 1, it depends. So in 2013 it was top 3 attack still being used, and it's 17 years old, which is pretty bad. So the developers, we are failing at stopping this attack. So I want to talk about the attack itself, how to fix it, and then I will talk about content security policy, which is a second line of defense for cross-site scripting, because developers are failing at doing a lot of things and also at stopping cross-site scripting attacks. So this second line of defense should probably help developers to stop the cross-site scripting attack. We'll talk about that. So what is a cross-site scripting? It's still present at a lot of sites. For example, I was able to find a cross-site scripting attack at one of the mobile operators in Czech Republic. I won't name them, but probably you can recognize them. It's the pink one. And it was actually quite easy. A friend of mine told me that he had a presentation, I think 2 weeks ago, and he was talking about, he said that some of the users are different. Where the common users, where the regular users of the internet, where they see a form, these different users, they see a cross-site scripting attack. And then he showed my photo. I was like, oh, who's that? So I'm trying to, whenever I need to input something and I don't think it's important, I just try to use a JavaScript, because why not? So this happened. I tried to enter JavaScript in my address when I was registering, when I was signing up with this operator, and then suddenly, every time I log into their site right now, I just see the alert 1, which is written here, which is like displayed here, every single time. And I even reported it to them. I think they even gave me a bounty of like, I don't know, $30 US, which was actually like more like a donation, not a bounty. But every single time now I sign into that site, I see alert 1, which is cool, because I need to press OK, and yeah. So even they are failing at, protecting users against the cross-site scripting attack. There are more sites like these. I was able to find cross-site scripting attack at Bitbucket site. I was, they asked me to enter my SSH key so I can commit via SSH into that site. It's like a Git repository, so it's like a GitHub, but it's free, even for commercial usage. So I had to come up with the name of my SSH key. And coming up with names in IT, it's the hardest thing ever, right? Coming up with names. So I said, yeah, I love my SSH key, but I don't know, it's got no name. So what should I put there? So I actually put a bit of JavaScript. Script, alert, XSS, end of script. And I was kind of surprised that when I loaded the page, I was like, oh my God. Yeah, it was actually, the JavaScript was executed in the page, in the context of the page, in the context of my user. It's like, oh my God, that's bad. You see that the whatever was written in the name, in the label of the SSH key, it's actually written in the page. It's pretty small. Here, it was actually like echoed into the page without any sanitization, without anything. I was like, oh my God, okay. So I reported it to them. They said, yeah, it's bad, because I could create a team and I could invite other users, send the email to the unsuspecting users, and they would just go into this page and my JavaScript would execute. So this is pretty bad. So I was also able to find a cross-site scripting at one of the quite important sites. It's like, a password manager. Anybody knows LastPass? Cool. So I was able to find a cross-site scripting. It was really simple and not really dangerous at the LastPass, which is like the online password manager. And again, LastPass is not my primary password manager, so I'm using a password generated in some other password manager. So I don't remember my password when I need to log into LastPass. Probably I'm using LastPass wrong, but still. And so they wanted me to enter a password reminder. Like, well, but I don't remember my passwords because it's written in the other password manager, so I don't need to remind myself what this password is. I said, yeah, let's just put some JavaScript there. Why not? Because that's what I do. So I put script, alert, XSS system, password reminder, end of script. And damn it, yeah, I was surprised that it actually got executed as well. I reported it to them again, but this was not really dangerous because this was executed only in my context. I couldn't attack any other user because I would only need to tell the user to, go and change your password and put this JavaScript inside the password reminder field. Well, I'm afraid it would work in some cases, definitely, yeah. That's what's described as self cross-site scripting. It works with Facebook users pretty well because you tell Facebook users, hey, go into your browser, into the developer tools, open console and paste this. And then you tell them, and you will get Facebook with all the design, or you will get pink Facebook, or you will get, I don't know, something from us. So they go there, they just paste the JavaScript there, and that's it. Their account gets hijacked. So that's why Facebook is actually, if you open the developer tools in Facebook, go to a console, you will see a big warning that, hey, this is a feature intended for developers, just don't do anything and go away. But yeah, this is a self cross-site scripting. Actually, you cross-site script yourself, which is pretty bad, but yeah, sometimes it works. So yeah, sometimes also what works quite a lot is, the developers are kind of used that they should probably escape or sanitize the user input, which is like a search field, address, or I don't know, the orders, nodes in the orders and stuff like this. But what works quite a lot, surprisingly, is putting a JavaScript into the username. This is kind of like, okay. So the thing is that the developer's job is actually to output the username. If they need to echo the username, they just echo the username because that's their job. And every time they need to think about something more, every time they need to put more effort into securing the application, they will fail. Because your job is to echo the username. Your job is not to make it secure and then echo the username and stuff like this. So your job, somebody told you, hey, echo the username, so you do that. And putting any extra effort is bad because you can forget it, and well, a lot of developers do. So right now, in the name of the presentation, that's also a barbecue. So I think that we might have time for a small demo of what actually cross-site scripting can do, because alerting one or alerting XSS in a page, that's boring. And quite a lot of actually managers, they think that, oh yeah, if I report the cross-site scripting at that site, they're like, yeah, cross-site scripting is the alert one, right? We don't care about that. That's cool. We just press OK and that's it. So JavaScript, no, the cross-site scripting is much more than just alert one or than just alert XSS. So I want to show you what actually cross-site scripting can do, what JavaScript can do. So let's see, and we can have right now the OMG WTF time. I want to invite my good friend Beef, and Beef means Browser Exploitation Framework Project. That sounds a bit scary, right? This is a framework for actually using or exploiting a JavaScript in browsers. This framework, it's a framework, so you can actually also use, you can write your own functions into that framework, so you don't need to use it as, you don't need to use it out of the box, but actually it works out of the box, but you can put your own modules into that framework. So if you need to attack particular users, you can actually tailor it to suit your needs. So let's see if we can actually see the demo. Let's see if it's gonna work, because sometimes that's with demo. So should I start? Okay. So let's see who's of you got. Yeah. So can you actually cooperate with me a bit? Okay, so can you go to a site which is called POKL.cz? If any of you want as well, you can do that, because experiencing cross-site scripting firsthand, it's actually quite nice experience. But I will just use another browser so that we see it as well. So I wanna showcase what actually a cross-site scripting can do. So I will just put my browser somewhere. Let's see. I'm gonna try it like this. So let's imagine this is the victim browser. Oh, poor Firefox, but yeah, it's a victim right now. So imagine I got a site like this. This is it was built by me, so it looks pretty shitty, but it's gonna work. So this site is supposedly a e-commerce site where you can buy something. You can't, because it's my site and I don't wanna sell anything. But you got a fields for comments here. So whenever I actually input something, so let's say I want to write a review for that product and I want to say it's really cool, so I just write, let's say a director of something, it's cool. So I just write this, and I add a comment, and yeah, the comment was added, so cool stuff. Also, there's an admin side at this website. Because and I can actually delete the comments. I can't because it doesn't work. It's a demo site only. But imagine that you will be the admin of that site. So if you go to POKL.cz/admin, you will see the admin page. Imagine that you are an admin of that site or of that e-commerce site or something. So you just go there. And you see the comments. You might delete them. It doesn't work. Don't worry. But if you go there, so I will just actually go there, all right, in the other browser. So I go to the admin side, and now I could click delete if it's gonna work, but it doesn't. Sorry, the site is in Czech, but you probably get the idea, right? There's a delete button. So there's a button. So even if you don't understand it, just click it, and something happens. So right now, I'm switching to the other browser, and now I will be a evil internet user. That's what I do sometimes. So instead of just writing a job description there or a position, I write my name. Let's say evil dude, and then right now I'm gonna actually I will make it bigger for you. Just give me a second. Okay. And now I will actually use, instead of writing my name, I'll just write script search, and I will try to load a JavaScript from a URL address. Because why not? That's what I do. So let's just put it there, and just hello. I add the comment, and now the comment here is actually written as you would expect it to be, because that's what I wrote there, so that's what's there. It's cool. But if we reload the administration now, so if you guys can reload the admin right now, don't worry, it's safe. I'm a professional, so it's under controlled conditions, so everything is safe. So now right now, if I reload the admin side, there is a difference. See the victim on the here, and you don't actually see the JavaScript being written into the browser. It actually is, but it's not escaped correctly. It's just unsafe there. So right now it's like, yeah, probably the JavaScript got downloaded and it got executed. So let's see if we check it in the source code, we will see that the JavaScript actually is there. Oh well, damn it. See that the JavaScript is somehow here, the script hook.js. I can make it. Oh come on. Right. See, that's exactly what I wrote into that field. So it's there, which is cool. Because right now, what happened? This evil guy somehow persuaded this victim guy to download the JavaScript. And no alert, nothing, it's pretty invisible. And what happened right now is that this poor guy, the victim, and also all of you guys, sorry for that, sorry for making you victims now, got somehow hooked into this framework. This is the B framework running on my side. I'm an evil guy, and this is the poor victim. So right now, all of the victim guys, and thank you for cooperation, got hooked into this B framework, into this, yeah. This is like the control server for the framework, and I sent a hook, JavaScript hook, into this poor guy. So right now, this poor guy is communicating, is connected with this evil browser, with this evil control server. And also, you are actually connected to my server right now, and I can talk to your browsers right now, even without you knowing that. So I can check that probably, well, yeah. So I can see, I'll make it bigger. So I can see what browsers are there, you know, cookies and just everything about browsers. And this is just powered by the JavaScript, nothing else. This is just JavaScript. And I also see, you know, what happens in that browser and a lot of things. The framework is pretty powerful. But what I can do right now is I can send commands to these browsers, to these hooked browsers, to these victims. So if I go to the commands tab, if I go to the, commands tab, I got like, I think it's around 300 commands which I can send to the browser right now. So, you know, I can just, the most interesting one is the social engineering, which is pretty cool. We will see that. But let's start with something slightly, you know, easier. The control server or the B framework can also be controlled via the API. It's got the JSON API, so if I want to send commands to, say, 200 browsers, I just use the API and send it to all the browsers. So I just do that. I just send something to all the browsers, and let's see what happens. What I did right now is I sent a play sound command to all of the browsers. So maybe some of the browsers should actually start playing a Star Wars march, I think. Oh, no, they don't. What happened? Come on. Yeah, demos, damn it. Give me a second. Play sound. Play sound. What? Oh, it's not working. Oh my god, yeah, it's demos. Because I haven't actually executed. I had something on the command line. Sorry for that. So right now it should work. Yeah. So without even doing anything, you know, you just visited the site, and right now I can control your browsers. You know, it would be pretty stupid to play a Star Wars, you know, song at your browsers, but it's pretty cool if you got, you know, a room full of, let's say, 100 people, and they are like cooperating. Everyone is cooperating with you, so you just play a Star Wars song, and they're like all of them, all of the laptops in the room start playing Star Wars song. It's like what? Okay, so, but if you reload the page right now, it should stop. But I want to continue. This is pretty boring. I mean, yeah, Star Wars are nice, yeah, but what happens now? I can send a fake Flash update to that browser, and that poor victim guy, actually right now, it should be on his screen. Like, hey, there is an update for the Flash player. Oh, cool. So yeah, there's an update for the Flash player. It looks like an update for the Flash player, right? And that's it actually without you doing anything. It's just controlled by my control server, so I just send a command to your browser and it does that. You're like, okay, they wanna, yeah, they want me to update Flash, probably another security vulnerability, so I should update that, right? But this actually is a fake Flash update, of course. It was done by the B framework, so if I right now click the install button, what happens? Yeah, it will probably direct me to a site where malware will get installed, of course, like a persistent malware or something like that. So it's safe to click it right now because it won't install the malware, don't worry. They got my name, so I can't install malwares on your computers. And so, yeah. So if you would need to hack somebody, just install something on their computer and like persuade them to, that. But installing stuff on computers, okay, can do that. But right now, we are after passwords. Let's say that we are after passwords. So you just, if you can reload the page so you don't see the flash update. So I can also execute, let's say, social engineering Google phishing page. Without doing anything, right now you just see on your screen a Google login page. It's a fake login page, of course, because if you're careful, you will see that the URL is pretty fishy. It's actually, yeah, it's a lot of fishy. It's actually a phishing. But maybe some of the users wouldn't notice. And also this design is pretty old, probably it should be redesigned, but it's a fake Google login page. So if right now we type something, try to type something in, you don't even need to submit the form. Just try to type some username and password. Please don't input your real password. I got it already. So let's say hello something. I don't even need to submit the form because let's say I start to type the password and then I notice, oh damn, the URL is wrong, so I shouldn't type it. Okay, I shouldn't submit the form. But it's cool, I didn't submit the form, so yeah, everything is safe. But if we go back to the control server, so right now, let's see which of the browsers is mine. Google phishing, oh yeah. I'll just make it bigger right now so that we see the, I don't see any output, how come? Oh yeah, the thing is that even without you actually submitting the form, without the victim submitting the form, the browser actually installed a keylogger into the browser. It's not persistent, so if you reload the page, it's gone. It's not persistent, but it's just installed with the current, let's say, cross-site scripting session. So I have typed hello, and I wanted to type something into that field as my password, but without actually submitting the form, the keys got transferred into the control server. So I could have the password actually without the victim submitting the form, which is pretty cool, right? So this cross-site scripting thingy is pretty dangerous because it can do a lot of things with the JavaScript. It's not just alert one. It can do a lot of sneaky and fishy things in your browsers. So let's have let's try a last one. Which is, okay, where is the victim? Here you got the victim, I'll just reload the page. And, okay, I'll just reload the page. And now, let's see that you want to have the password for a particular user of this administration site. Because, let's say, I want to have the access to the administration as well, to the administration page, but I need a password. So what do? Well, I ask for the password, right? That's the easiest way to do. Don't hack the passwords, don't crack the passwords, just ask for the password. So let's do that. So I ask for the password. Yep. I present a your session timeout window. This is what the user will see. This is what you see. This is what you should see as well. You are like, okay, my session has timed out. And you see that the logo is also the same. Well, the logo was designed by me, so it's not the real logo. This logo the logo is the same, so it looks pretty, it looks pretty real and pretty legit. It's on the correct URL. Also remember, check that the site is actually running on HTTPS, so it should be, safe. But cross-site scripting doesn't care about HTTPS. HTTPS will not make your site secure. HTTPS makes only the transfer secure, nothing else. So that when I transfer JavaScript into the browser, it's safe. But yeah, so I presented this kind of login window into the user, and they're like, my session expired. Well, okay, that doesn't happen too often, but probably the IT department, they know what they are doing, so I should probably, enter the username and the password. So I just type a username, password, and I submit that, and yeah, that's cool. Okay, it works again. But this login screen was fake, of course. and it got transferred to my side, to the control server. So again, where is that? It's here. So again, I got the credentials right here, right now. So this is what cross-site scripting does. This is like the I'll call it the holy grail of cross-site scripting. This is like the most advanced cross-site scripting. It's not just alert one. It's a lot of things you can do with JavaScript. You can also, if the JavaScript is running in your browsers, you can also scan the internal network to find some hosts, because JavaScript can initiate requests, right, using the XML HTTP request interface. So using AJAX actually. So you can also scan the internal network using JavaScript, and you can do a lot of things with JavaScript. It's not just alert one. The alert one is just to find the cross-site scripting and to show that it actually works. But once you can do alert one, you can do anything with the JavaScript. You can also present the user. That's pretty cool. If you reload the page right now, if the victims would reload the page or exit the browser, of course, the connection with the control server and the victim is gone. But you can present a nice little window like, hey, there is an update for this browser extension, so please click that, and they will install a browser extension which will like make the Beef framework persistent in their browser. So every time they launch the browser, Beef is there and they got connected into the control servers. So cross-site scripting is pretty dangerous. It's not just about alert one. It's this. So right now, how to actually protect against a cross-site scripting? So oh yeah, sorry, because that's what we care about, right? So once we actually echo the username, we should somehow make it safer or somehow sanitize it. So what we should do is to call HTML special chars function. This is like the basic stuff. This is like the most easiest way to do. The thing is that the HTML special chars function name is pretty long. It's got like 16 characters. So it's like nobody types that because that's too long. And if you need an extra effort to make something secure, yeah, you will forget about that. Trust me, I've done that as well. So typing HTML special chars every time you need to output something, that's quite boring and bad, and yeah, people will forget about it. Also, the thing is that HTML special chars, like itself, is not enough, because HTML special chars, just like this, it converts only 3 characters to their HTML entities. It's the the starting HTML tag sign, the arrow, the other arrow, and the double quotes. By default, it doesn't convert a single quote into the HTML entities. So if there would be a code in the side like this, this is supposed to be JavaScript code. So when you got the JavaScript code and you output something into the JavaScript code, you output the user input, this HTML special chars won't help. Because by default, it doesn't convert the single quote into the HTML entity. So what we should do, we need to call it like this, HTML special chars with a flag and quotes. This is like another 10 characters. So to make the output secure, you should type 20 more characters. This is like an extra effort, and that's not really gonna work. Typing 20 more characters to make one single output secure, it's not gonna work. So people don't just do that, because why should they? They don't know what cross-site scripting is, and if they do, they're like, yeah, it's the alert one. Nobody cares about that. Much better thing is to use any templating system, because then you can actually type you don't need to type the echo HTML special chars function and everything. You just type the row username, and the templating system will escape that and call the HTML special chars function automatically, which is cool. If you don't need any extra effort for making something secure, it's cool, because you cannot forget about that, and this is what we need to do. So that's what I tell a lot of developers like PHP developers, I mean, to use any templating system which does escaping automatically. That's cool, because you don't need to think about making any extra effort to making secure. So yeah, this is like the first line of defense, to output the stuff in the browser in a secure way, to send the stuff, to accept the user input, make it secure or make it safe, and send it to the browser escaped. But we are seeing that developers are failing, that we are failing to make it secure. So we need to introduce a second line of defense. Second line of defense is something which should kick in when the first line of defense fails. When developers fail, then there should be a second line of defense which might stop the attack. Browsers have that built in already. Browsers like Chrome and Internet Explorer or Edge or anything related to these browsers like Safari, anything built on WebKit or anything built on Chromium, they got a second line of defense built in. It's the, they call it XSS auditor or XSS filter, and it works automatically. It's on by default, and but it cannot actually protect the user from all the cross-site scripting attacks. It can protect them only from the reflected variant, where the user gets sent a special link. It works in the way that the XSS auditor in the browser sees the link, sees the URL, so the browser sends the request to that URL, and the browser sees that there is something coming back. So the browser compares the URL if it contains any JavaScript, and if the JavaScript is coming back from the server, it's a reflected cross-site scripting attack, so the browser blocks it. So he compares the request and the response. And if the request and the response contains a JavaScript, the same JavaScript in the request and the same JavaScript in the response, it's probably a reflected cross-site scripting attack, so the browser blocks it. Actually, the browser doesn't block the request, the whole request. The browsers try to somehow repair the page. So that actually you see something, at least something, but the JavaScript is not executed. What's safer to actually block the whole render of the page, to not render the page at all, because there are some cases described where the browser, when the browser tried to repair the page and remove the evil JavaScript, they actually made the JavaScript even worse. So it's easier and it's safer to actually block the rendering of the whole page. If there is some reflected cross-site scripting attack, just block the whole page and just don't do anything. This can be achieved with this HTTP header, XSS protection value 1. It means that the XSS auditor is activated, and mode block means if there is a reflected cross-site scripting attack, just block the whole page. Don't render it at all. Don't render it at all. Just block the displaying. I think that the browsers will display a blank white page, but it's still better than if the user will get cross-site scripted somehow. There is a special extension, not really standardized extension, which works only in the WebKit browsers and in Chromium browsers, and it's this report extension. If the XSS auditor gets activated, the developer has no idea that it got activated. But with this report extension, you can, the browser can send a report to you, to send the report to that URL which is written in the report extension. So at least you know that there was something wrong, and you can fix it in your site. But this extension is the report extension is not really standardized. As I said, it works only in Chromium and Chromium-based browsers and WebKit. This report is actually a simple JSON which contains two fields. One of them is request URL, the other one is request body. So you can actually make a reporting script yourself and just save these two fields in the log file or somewhere, and then check the log file. And then you will actually see if there is any reflected cross-site scripting being used against your users. So sometimes with logs, nobody checks the logs, because why? But this log should be empty. And once there's something there, probably the cross-site scripting auditor gets activated or got activated, and you should investigate more. but it's not standardized extension. It doesn't work in Firefox, it doesn't work in Edge or Internet Explorer, so, but it's still at least something. Well, what is probably a better solution to second line of defense against cross-site scripting is CSP, Content Security Policy. This is a standardized thing already. It's got 3 versions already, and it's pretty powerful. So let's talk about CSP a bit. What does it do, how does it work, and how you can actually defend yourself or defend your users against cross-site scripting attacks. This XSS protection and this XSS auditor works only against one type of the cross-site scripting. That's the reflective variant. CSP is more general. It can protect the users against the other variants of cross-site scripting as well. So Content Security Policy, CSP, is a HTTP header, like HTTP response header, which comes from the browser to this, sorry, no, the other way around. HTTP response header, which comes from the server to the browser. And this header tells the browser what the browser can load and execute. It's like a whitelist of things in the page. So you can tell the browser to load pictures only from this domain, execute JavaScript which is coming only from this domain, or don't execute it at all. Load CSS, the cascading style sheets, only from this page, only from this URL, which is pretty powerful because you can tell the browser that don't load any JavaScript, any pictures, don't load anything from other domains but mine. Just load only JavaScripts and load files and everything just from my domain. And if the attacker is able to insert or inject into that page any JavaScript, it will actually get sent from the server to the browser, but the browser won't execute it because it's forbidden by this content security policy. So let's try to build a content security policy, a simple one and an example one. So if you would send this header from server to the browser, and actually it's an HTTP header, so it can be different for every single site, for every single page on the site. So what I actually suggest a lot is to definitely use it at the administration pages because they are kind of a nice target. So it should be used definitely at the administration pages, at the administration side of that website. So a simple content security policy header should look like this, or can look like this. We instruct the browser to load something, to load stuff, pictures, JavaScript, cascading style sheets, only from the domain of the page. Self enclosed in the quotes means like the self domain, the domain where the page is. So it wouldn't load JavaScript coming from my attack server. It wouldn't load JavaScript coming from Beef server. It wouldn't load JavaScript from Google Analytics. It wouldn't load JavaScript from anywhere except my domain, where from where the header got sent. Default search or default source is like a group of other directives, and that means every single directive which got the source attribute is somehow falling into this group. So by default, no JavaScript, no images, no cascading style sheet, no, well, I don't know what else, except when it's coming from my domain. So this way we are already protecting the users against cross-site scripting pretty nicely by just issuing one HTTP header. Let's make it more difficult. We can also instruct the browser to load images only from my domain and from googleanalytics.com because we need tracking Google Analytics code to be present on the page. So we tell the browser to load everything from my domain, and then we extend the images to load from my domain and googleanalytics.com. We also need to extend a script because Google Analytics they also need to load JavaScript from googleanalytics.com side. So by default, the first line, we load everything from only my side. We allow the browser to load everything only from my side. Then we extend images, and then we extend also scripts and we allow scripts from my domain, and we allow scripts from googleanalytics.com. So Google Analytics tracking right now should work. There's more directives like this. Thing is that unless you allow unsafe inline, no inline JavaScript will get executed. Inline JavaScript is on mouse over handlers, on error handlers, and everything, and every JavaScript which is written between the starting script tag and the ending script tag. Everything which is written directly in that page, not in the external files. That's an inline JavaScript. And unless you allow the unsafe inline directive, no inline JavaScript will get executed. So even if the attacker is able to inject JavaScript into that page, script alert 1 end of script, it will come to the browser, but browser will have this policy enabled, and it will just not execute it. It will be in that page, it will be in the HTML, but it won't be executed unless you allow the unsafe inline. And you see, it's unsafe. So even the authors of the specification think that inline JavaScript is unsafe. You can also, the other directive is, which you should enable, is frame source. That means that I can load frames from this YouTube no cookie domain into my page. Otherwise, if it's not enabled, I wouldn't be able to put any iframe inside my page, because it will just get blocked, because it's not in the default source. So the default source says that everything can be only from my side, but I need a YouTube video on my side. So I just enable frame source only from YouTube no cookie. But I don't enable self inside the frame source directive, so I will be able to put iframes into my page only from YouTube nocookie.com if I need a video from there. This directive is pretty interesting. Form action self. It means I can restrict forms to be submitted only to my domain. If there will be an attacker injecting an HTML and injecting a fake form, they cannot, they might be able to inject the form, but they won't be able to make the user submit that form to their site. Using this form action, I can instruct the browser to submit forms only to my site. Why is that a good thing? Well, because HTML5. HTML5 is pretty cool, right? But it got this nice feature. It's pretty interesting. You can, when you need to submit a form, you need to have a input type submit in between the form tags, right? To submit the form. But in HTML5, you don't need to. You can just put input field into the HTML anywhere, not even inside the form tags, just anywhere. And you can connect this input field with that form by using a form attribute. Let's say that the form, submit form or something, will have the ID form1. So right now you connect this input field with that form, which is somewhere completely, somewhere completely else, it's somewhere in the page. And you can just connect this submit button with that form by using this attribute. This input field can be anywhere, not inside the form, which is pretty interesting. You can submit the form by any button if you actually add the form attribute. And you can also change the action attribute of that form using the form action attribute in that input submit button, which is pretty strange. I don't know why it's there, but actually it's there. So you can change the form, which is in the different part of the page, by a button which is somewhere in the page, and it can change the form to submit to a different URL than what's written inside the form field, which is pretty strange. So if the attacker would be able to let's say, inject this HTML code inside the page somewhere, they can maybe persuade the users to click on that button, well, especially if you name it don't click, right? So they can click on that button and the form will get submitted and will get sent to the attacker's URL. So they might steal some CSRF tokens or something like that. So to protect against this, we use the form action self. It means that this won't work. It means that the forms can be submitted only to my side, which is pretty important detail. So one more detail is also the object source here. That means that we won't be able to add any HTML which will load Flash players or Flash videos or Java applets or something like that. Because you can also do cross-site scripting via a Flash video. It might be vulnerable, so even if your page is perfectly secure, if the attacker would be able to insert a Flash video, they can cross-site script the user. So we disable any Flash videos on the site. And we can also send reports, which is cool. By using a report URI directive, we can also send reports. If there's something, if the policy will get activated in the browser, which means that if the attacker was able to insert any JavaScript, any fake forms, anything like that, and the policy will block it, you can also know that by browser sending you a report, so that you know that there's something wrong and you can maybe fix it. Well, I would recommend to fix that stuff. So you can write the report URI directive and send the reports to your URL. These reports, these content security policy reports, they are much more complicated. There's much more data and there's much more noise because people get viruses on their computers. People get fake extensions in their browser. Sometimes they are on free Wi-Fi networks, and these networks actually inject JavaScript into their pages to display ads. So this policy gets activated pretty often, quite a lot actually, even without any vulnerability in that side. So instead of building your own reporting tool, you can use the reporturi.io, which is written here. That was built by my friend, and it's supposedly, I think that's the only tool to handle the cross-site scripting and content security policy reports. It's quite a nice thing. It looks like this. It's much more powerful. It's got also charts and everything, so you can see when there is a chart with a spike that they're like, oh, something is wrong probably on that side and I should fix that. So I wouldn't suggest to write a reporting tool yourself because that's pretty difficult task to filter out all the noise and everything. But I just use these reporturi.io for that. It's free, and you can send all your reports to that site. And it will get some details like when does it happen, what was the URL, which directive got activated, and what was the URI which got blocked. And so you can actually fix that. This is a report from my side, and I forgot to enable something. I forgot to enable loading images from some other domain. So I could see that in the report, and I could see that in the charts because there was a spike. So yeah. If you would love to use a a content security policy on your side, it's pretty difficult to actually get it running on a site which is up and running for some time already, because it's pretty complicated. But you can use a content security policy report only, which is the first line. That's a special header which says to the browser like, here's the content security policy, and if it gets activated, don't block it, but just send me a report, so that you actually can know that there's something wrong. So that you will get the reports, but the browser will work just like it should. Even it will just load the pages from wherever, but it will get reports if the policy gets activated. And this is pretty useful for sites which are running for some time and you want to introduce content security policy. And I would suggest to start with this, with the report only. This policy is actually activated for every single JavaScript, or for every single resource which is being loaded into that page. That means, for example, a Google Tag Manager is a tool for managing JavaScripts, and it's used pretty often. So if you use a Google Tag Manager, you need to enable loading JavaScript from Google Tag Manager, but you need to also enable loading JavaScripts from every single other JavaScript file which the Google Tag Manager inserts. You insert a Google Tag Manager, it's like a JavaScript Manager thing, and this Google Tag Manager can load some other JavaScripts. And you need to enable the script source policy for every single JavaScript file which is being loaded by the Google Tag Manager. And this is pretty, not easy. It's pretty hard because somebody else might use the Google Tag Manager and they can just insert any JavaScript file, and you need to update the policy. It's pretty bad. So there's a CSP 3, CS Content Security Policy Level 3, which somehow fixes that. And they fix it by strict dynamic. So if you use script source strict dynamic, it means that once you insert a JavaScript into that page, all of the other scripts which will get inserted by that script will somehow reuse the same policy and will reuse the trust. So if the script is enabled in that page, all of the scripts will be enabled as well. So that's a cool for Google Tag Manager, because once you insert Google Tag Manager, once it's allowed, by using strict dynamic, you will allow all the other scripts which get inserted by Google Tag Manager as well. Well, the thing is that strict dynamic only works when you mark your script files or script tags with a nonce. It's a random nonce which gets changed every single reload of the page. So you need to mark your script tags with a nonce, and then you insert the nonce into the script source header. And you mark these script tags as enabled, and they will get executed in the browser. And if there is a strict dynamic, this is the only way how to actually mark the scripts as allowed. Because if you use strict dynamic, all the host-based whitelists, they are actually disabled and they do not work. For the browsers which do not support Content Security Policy Level 3, like Edge or some other older browsers, you can add a unsafe inline and host-based whitelists, HTTP and HTTPS. This means that the browser will load scripts from HTTP and HTTPS, and all of the scripts will get executed, even if they are inline. This is like a fallback for the older browsers. And again, remember, Content Security Policy is a second line of defense. So it doesn't really matter if it doesn't work for the older browsers. It's just a second line of defense, and it's cool if it doesn't work for all the browsers. And in that case, you should also disable inserting of Flash videos. We have been talking about that already. And you can send the report to that reporturi.io site. And so this is like the recommended content security policy for sites, and you can actually use that, and you can start using that right now or today or maybe tomorrow. And if you start, I would suggest to check with this site, cspevaluator.withgoogle.com, and they evaluate your CSP policy. So they tell you if the policy is okay or if it's not. Because the content security policy is pretty difficult specification, and there are bypasses. Like that, you allow the library to be loaded, but this library is vulnerable, so it can be bypassed pretty often. So this CSP evaluator will tell you if the content security policy is okay or it's not, if it can be bypassed or if it can't. And you can also find this sample safe policy there, so you can just use that site and check your policy and get inspired there as well. So I would suggest to at least check content security policy, because second line of defense, which is pretty powerful and can do a lot of things with browsers and can stop the attackers like me. And that's it from me. If you are using Twitter, you can follow me on Twitter. I sometimes post interesting stuff regarding content security policy and some other attacks. So that's it from me. Thank you. Thank you.